Okay, so here we come with number 4 in the review parade for exam 2. Okay, so M108 spring 21 exam 2 review. We're up to D. Taking a while. We did 9A on the previous video. Here comes 9B. They're actually not related, so it's pretty convenient. You don't need to know something from the previous video in order to do 9B. It's something different than 9A. Here's what happens in B, 9B. Roll dice to get extra turn in game. All right, whatever. To get extra turn. In game. All right, I'll just put the whole thing in game. Okay, now probability of extra turn. In other words, they're giving us this information. The probability of getting an extra turn in the game is 5/18. So we got the probability information. Question: find the odds. They give us the probability. The first question was the opposite. Now they give us the probability and they want us to find the odds for extra turn. Okay, answer. The answer is what are the chances? We want there's going to be separated by a colon, right? The left-hand side will be the chances for an extra turn, and the right-hand side will be the chances against the extra turn. Well, the chances for an extra turn are 5. But what are the chances against an extra turn? 18 minus 5, which is 13. The total adds up to the entire sample space of the probability. But the chances against the extra turn are 13. 18 minus 5 is 13. And the chances for it is 5. And this is what you write, or you write 5 to 13. Both of these are correct ways of putting odds. We went from probability to odds in this problem 9b. In 9a, we went from odds to probability. Okay, we are now ready for problem number 10. Let me move up the paper. Why not? I do have some room for 10. 10 is not so long. 10 is not so bad. 10. What is here? It gives you don't even have to know anything about combination, in other words, the theory of combination, but you do have to know the formula to answer this question. This is 10A. Okay, answer. This is the question. The answer. You just have to work out with the formula. Remember the formula. 9 probably take the this is the n, this is the r. So it's 9 factorial over r factorial. Remember the formula. 9 and 9 minus 5 factorial, which is 4 factorial. So working out some of the numbers, this is not so hard to work out, and I don't need a calculator really, so I'm happy I'll just do it. Take the biggest one on the bottom, it becomes 9 times 8 times 7 times 6 times 5. I'm sorry, times 6. That's it, and stop, don't take it. I didn't even listen to my own advice. And then 4 factorial is 4 times 3 times 2. I don't need the 1. What happens over here? The 4 times 2 cancels with an 8. 4 times 2 is 8. They take each other out. And then the 3 goes into 3 once, and it goes into 9 3 times. You're left with 3 times 7 is 21. 21 times 6 is 126. And that is the final answer. Problem 10b is you have to remember the formula for permutation. 9p3. Okay, that's the question. The answer. Should have put 2 dots there. 2 dots there. What's the formula for permutation? N factorial, which in our case is 9 factorial, over n minus r, 9 minus 3, which is 6 factorial. So remember the formulas. CNR is n factorial over r factorial n minus r factorial, and p n r is n factorial over n minus r factorial. Right, this is supposed to say factorial. All right, anyway, so that's 9 factorial over 6 factorial, which is equal to 9 times 8 times 7, and then stop. How much is 9 times 8 times 7? Well, it's 9 times 56, and that's equal to 504. You can check it with the calculator, and the problem is over. That's problem number 10, new piece of paper. Okay, let's go to problem number 11. Problem number 11. A is a set. What is it the set of? Integers. It's a set of integers that are greater than minus 6 and less than minus 2. Okay, B is another set, and B has the following elements in it. It's got HI, M, and then it's got SUV, and then it's got WY. Okay. Now, question A. What is n of A, meaning the cardinality of A, meaning how many elements are there in A? Answer, there are only 3, because negative 6 is not one of them. It's got to be greater than negative 6. So negative 5, put it, you can now count on your fingers. Negative 5, negative 4, negative 3. Once you get a negative 2, don't take negative 2 because it's got to be less than negative 2. So there's only 3 elements in there. What is the n of B? Count up those elements in B. 1, 2, 3, 4, 5, 6, 7, 8. Is it 8 or is it 7? 1, 2, 3, 4, 5, 6. Yeah, it's 8. Is equal to 8. All right, so that's the amount of elements that there are in B. How about, well, here comes C. C is going to be as follows. Let me put it over here on the right-hand side. C. Here's the question, true or false? Minus 3. Is that an element of A? True or false? Check off true or false. Minus 3, is that an element of A? Well, check it out. Minus 3 is in there. It's between negative 6 and negative 2. So it's true. Next. Is negative 13 an element of A? Absolutely not. It's nowhere near. So it's false. Next question. Is W an element of B? W's in there. So yes, true. Next question. Is E element but not an element of B? Is E not an element B? Yeah, E's not in there. So it's true. And that's it for problem number 11. Let's move this up. We can get problem number 12 on here too, I believe. It's not that big. And let's cordon off space, just in case we need it. Here we go, problem number 12. You've got 9 small stars. 9 small stars. They're stickers or something. Let's say they're stickers. 9 small stars. Okay, 8 big stars. You've got 10 rockets. I'm sorry, 10 small rockets. Small rockets. And you've got 10 big rockets. That's the information. Here's the question. What's the probability of getting, you pick one at random, as usual. You pick one at random. What's the probability of getting a small or rocket? You pick out a sticker, and either you get a small one, whatever's included in small, and whatever is included in rocket. That's the question. Answer. Well, the 9 out of 30. How many are there altogether? That's the first thing to figure out. How many are there altogether? It's because it's a probability, right? So we need a denominator. How many are there altogether? There are 37. Let's count them to make sure. There's 19 here, and there's 18 here. What's 18 and 19? 18 and 19 is 37. So there's 37 in all. That's the denominator of our probability. So now, small. If it's the small stars count for us. In other words, is that what we're interested in? Yes, and there's 9 of them. Right? Small or rocket. Are we interested in the big stars? No. It's not a rocket, and it's not small, so forget it. Are we interested in the small rockets? Absolutely. It's both small and a rocket, so we're interested in those 10 out of 37. Are we interested in 10 big rockets? Yes, because as long as it's a rocket, we're interested in it. So then add those 10, there's 10 of those too. So 10 out of 37. Right? So it's the 9 small stars, the 10 small rockets, and the 10 big rockets. Those are the ones that we're interested in. The only thing we're not interested in is the 8 big stars. Add all these up together, and you get a total of 29 over 37, and that is the final answer. Problem over. New piece of paper. Okay, get me to a new piece of paper. Here we go. All right, so now we go to problem number 13. Okay, let's get up there. 13. All right, so you've got, this is a lunch, some sort of lunch. All right, so you can pick your bun. There's the A type of bun, there's the B type of bun, and there's the C type of bun. You can pick a side order for a lunch. The side order. You can pick the D side order, or the E, or the F, or the G. And finally, you get to pick a drink, and you can take either an H drink, an I drink, J, K, or L. Question: how many lunches, different types of lunches, how many different types of lunches are possible? How many different types of lunches are possible? So I'll tell you one type of lunch, AEI. Another type, BEH. How many different types of lunches are possible? Well, it's the counting principle. There are 3 types of buns that can go with 4 types of side orders that can go with 5 types of drinks, and all those are the different types of possibilities for your lunch. 3 times 4 is 12, 12 times 5 is 60, and therefore the final answer is 60. This problem is over. Plenty of room here. Let's go to problem number 14. Oh, we'll have to do that on the next video. Problem number 14 is actually pretty big. We've got enough room on here, but we don't have enough time. Okay, so let's end this video.